All right, fantastic. Well, thank you very much for choosing to spend your Thursday evening today attending a workshop about technical interviewing. So this is, we're going maybe off the regular weekly script, and you will be working on a problem individually. So I do recommend having some sort of development environment ready, whether you have it installed on your computer already, or you can use some online interpreter for the programming language of your choice. And just to make it a little more fun, we also have a poll, which I pasted into the Zoom channel. So just 5 questions. Give it a go. I would like to learn more about you and your background, just so that I can tailor the workshop base to your needs in a more optimal fashion. And well, today we will be talking about winning at technical interviews. So if you want to get a job as a software engineer, this talk is for you. I will be sharing how to prepare for interviews, give you some tips on what to do and what not to do. And for the large part of this workshop, we will be going over a sample problem. So we will get our hands dirty, we will write some code, and that's why I asked you to have pen and paper or an IDE or something that helps you produce a code. And well, we will be talking about some serious, complicated things. This doesn't mean that we shouldn't have fun in the process. This is a workshop. This is not a lecture, certainly not a monologue. And I see we have a decent amount of people. I don't foresee a problem answering questions. I'll make sure to make sufficient pauses. Feel free to interrupt me or ask your questions in the Zoom chat. It's all good. All right. Well, who am I and why I am presenting here today? Well, my name is Diana, and 10 years ago, I graduated from Carnegie Mellon University, and I moved to Silicon Valley. Since then, I've been working as an engineer full-time. I managed engineers, and I'm currently a tech lead. So I've been at both sides of the table, meaning I've been a job seeker and I took interviews, but I also administered interviews, sat on hiring committees, and made hiring decisions. So everything I'm going to share today is really a product of this firsthand experiences, my observations, my ruminations on the process, and the content you will see today in this presentation is exclusive and not borrowed from other sources. And well, while I always enjoyed writing code, when it came to interviews, I was average at best. I don't want you to think that I was a natural. I aced my first interview, landed my dream job on the first try. Rather, I recognized that I had room to improve, and I focused on becoming better at interviewing. And well, interviewing is a skill, and it's a skill that has a huge rate of return. So now I enjoy coaching people because I've been in their shoes, I can relate to their struggles, and I have a lot to say as well. So let me take a look at the responses of the poll. Unfortunately, I can't share it. They don't really look very nice. But from what I can see, the majority of people who answered either have had no technical interviews or a few, 1 to 5. So I'm going to assume that you're looking for an internship or your first full-time job in the States. But even if you are watching the recording and maybe you have had a few interviews or you already have a job, please, I still think there is a lot to gain here. I invite you to think bigger, because you will be changing jobs throughout your career. So even if you already have a job, you're going to need another job and another job. So it's a great opportunity to strategically start building your mindset and your skill set. In terms of level of experiences, it sounds that we have a couple of people who are identified themselves as being new to computer science. That's totally okay and welcome. I just wanted to let you know that this workshop does assume that you have some basics of programming language already together. So I just don't want you to be discouraged if some of the topics that I'm going to present would be a little more advanced. They're just not meant for a target audience who is absolutely new to programming. And then the majority identify themselves as kind of somewhere in the middle, meaning they know something, there is always something new to learn. Funny enough, that's probably where I would place myself, despite 15 years of experience. And then in terms of people's feelings about interviews, I clearly see that worried is coming as a very, very clear first. And that's totally natural. I mean, interviews don't always feel good, and it's natural to feel nervous, and it's not a pleasant experience. Someone is essentially examining you. But I wanted to say it's absolutely natural because, in fact, all of these adjectives, I just Googled like 5 feelings that people feel during interviews, and these were the 5 adjectives that it spat out at me. So really, it's very common to be feeling desperate or worried or a mixture of excited. And, hopefully, as we gain more mileage and build confidence, then we start feeling better about our interviews. Remember also, actually, some level of stress has been proven to be conducive to better performance. So our goal is just not to be completely stressed and to have just that right level of stress and excitement to be able to perform at the optimum level. And then the last question of our poll was a trick question, and I see that nobody answered that going into college is very stressful, and I'm assuming that's because most of you have already got into college. So finding a job is leading, and then some people maybe already having a job answered that finding the life of your life is the most stressful. As I said, it's a trick question. An informal survey of all of my friends showed that finding the love of your life is absolutely the top most stressful thing. And because if you already have a job, it's typically not that bad. And remember, finding a job is so much easier than finding the love of your life. And I'm sure everybody will be successful here. All right, so now that we know a little bit more about each other, let me talk about what to expect, how to prepare, especially for the folks who have never taken an interview. So, what's a technical interview looks like? Honestly, it could look like anything. It's not a regulated profession, so realistically, an interviewer can ask you absolutely anything in the interview. Having said that, most of interviewers are not that creative, and I found that the most of interviews fall into a certain number of buckets, which I have come up with the following classification. So an interview can be a technical question, which is either close-ended or an open-ended. A close-ended technical question would be something like, tell me a difference between final and finally. Or could you explain to me how open address hashing works? As you might guess, you either know the answer or you don't. And that's because this kind of question evaluates your knowledge rather than your ability to solve problems. And in fact, I would say you probably want to be careful about guessing a close-ended question. I have seen that some interviewers appreciate the interviewees giving a question a try, whereas some others feel that they would rather you admitted that you didn't know rather than pretended that you here is an answer where it's not a real answer. So, well, that's the close-ended question strategy is, as I said, you either know or you don't know. And well, if you're interviewing for the right job, hopefully you know. And then there are open-ended questions. This typically would be something like, tell me your pros and cons of monoliths or microservices, or what are some challenges of doing event-driven choreography or orchestration? Well, typically these kind of questions would be asked for more experienced candidates who have already dealt with these concepts and have something to bring to the table. So I wouldn't expect you to be asked that many questions of that sort. And the same goes for system designs interviews. While they sometimes are used even for entry-level positions, normally design questions won't be asked until you reach a level of at least a senior engineer. So what are you actually going to ask? Well, the majority of your interviews are hopefully going to be coding questions, which is the topic of today's workshop. So a coding question can be delivered in two manners, automated or in person. Here you will be writing code to solve a very well-defined, typically short program. So this is quite similar to regular programming, but it's actually not the same because you have this defined program, you don't read other people's code most of the time. So in fact, I would say it's more similar to schoolwork because you have this very well-defined problem space. There is a known answer. You have to come up with a known answer. An automated coding question is a way to screen candidates through an online assessment. And we can imagine that the way this works is, well, the code probably has to compile, right? They have a set of test cases and your code will be judged based on its ability to pass these test cases. In other words, even if you are 5% away from making this code work, if it doesn't compile, then you most likely will fail this online assessment because nobody will be looking at the code you've produced. It will be evaluated by an automated system. And the strategy for dealing with this automated coding interview will be to always make sure that your code compiles and building up iteratively. So for example, maybe you won't be able to address all edge cases and you will be adding edge cases one by one. But at the same time, it's more important to have something working rather than having unfinished code at the end of the interview. Another aspect of automated interviews is that, there is no person on the other end, right? So nobody's going to give you any hint. You'll just be given a question and most likely you will be authorized to make whatever reasonable assumptions you can make in order to solve this question, just not a two-way method of administering an interview. And well, on the positive side, you can totally Google the questions. They typically try to make sure the problem is not Googleable, right? You can Google APIs, you can look up syntax or anything you like, but the solution to the problem is typically not available on the internet. You're just solving it with available sources. Which actually makes me in a way like this format because I believe this is very similar to how we're actually solving questions, writing programs in real life. In real life, I'm not presenting with a whiteboard in front of an interviewer, walking them through my thought process. In real life, I do some research online, I type some code, see if it works, and that's exactly the format that the automated interview is offering. And well, finally, automated systems typically have no bias, regardless of the color of your skin or your accent or your religion. None of that is going to be taken into consideration when this system evaluates your code. It's literally just going to run it for test cases, and your ability to pass those test cases is the only factor factored into the decision to succeed or not to succeed. Having said that, I've never seen anyone get to a job offer through online assessment only. So sooner or later, you will reach the stage where a code question is administered in person. This is quite different because you're expected to interact with the interviewer. They may deliberately or accidentally give you incomplete requirements or sound vague, and you should clarify those requirements and work with them to confirm your understanding. And you shouldn't be just shutting down for, I don't know, 10, 20 minutes and thinking. Typically, they ask you to think out loud. And I know that's a challenging skill to have because it's not how we normally solve problems. But in an in-person interview, you would be walking them through your thought process. And well, while every interviewer will be comparing your solution to some bar they have in their head, and I don't know their bar. But typically, small syntax mistakes tend to be more forgivable for an in-person interview. Again, it's best to clarify with them at the beginning of the interview. Actually, I'm seeing a trend that nowadays companies do ask for compilable code, even for in-person interviews, whereas a couple years ago, whiteboarding, obviously nobody would be typing up that code and checking if it compiles. So there are definitely things are changing all the time. But regardless, through an in-person interview, it's really simple to determine the handle a person has on their programming language, right? It's pretty obvious. If the person doesn't know how to code, is not at ease with the programming language of their choice, an in-person interview is a very simple litmus test to figure that out. And well, through all of these interviews, in my experience, your performance on the interview will determine the outcome of the interview. In other words, your resume and your background will likely not play a big role during the interview. They got you the interview, so they're still important. They just stop mattering during the interview. What I'm trying to say is that I've rarely seen interview feedback saying, oh, you know, the person didn't solve the question, but hey, they have an amazing GPA, so we should continue the hiring process. Or, well, they volunteer with this awesome entrepreneurship club. I've never seen this to be overruling any performance on the actual interview. And this actually, as a result, I think one trick is it pays to be brief on answering questions, because the goal of the technical interview is to assess your technical capability, and you're not there to tell a story of your life. That's different for any kind of values alignment interview. And, you know, if they ask you a question, you know, ask you to introduce yourself or talk about a project, don't start a 10-minute monologue. It pays to be brief, answer for, 45 seconds to a minute or two. And if they want to know more, they can always ask you follow-up questions, and then you can dive into detail. But basically, you want to have as much time as you need to spend on the coding question. And some companies, such as Google, as far as I know, don't even waste any time on introductions or small talk, and they just dive into the question. But that depends on the company you're interviewing with. Do people have anything to say or ask based on this classification of different types of interviews? Whoever has their hand raised, just go ahead.
Hi, so I have a question about how should we prepare, since I'm in boot camp and I'm also trying to prep for the interview.
Great question, and that's answer to that is going to be on the next slide. Gila, did you have something to say?
Yes, I've heard some companies also give you take-home assignments. Is that typically part of the process, or when would that be? Is that in addition to doing a coding question, or do you know if some companies do that instead of doing coding questions?
Yes, take-home assignments are somewhat normal, and I've done a few. Personally, I do like them because, again, they are more similar to what I do day to day, right? I'm not asked to perform in front of an audience. It's not a circus. I think of a problem, I do my research, and I can solve the take home. Now, as you might guess, the obvious challenge is, well, unfortunately, some people are not very honorable and they can ask for higher help to solve this take-home assignments. And that's the reason that normally no company would hire you based on just take-home or automated tests, because they actually want to see that you are the person who did all this work. And normally you can have many rounds of interviews. I mean, we try to make entry-level interviews short, but nonetheless, I've seen people saying, I had 5 interviews, I had 10 interviews, I had 8 hours of interviews. So be prepared for everything. One of the formats I do like is when they give you a take-home, but they ask you to present during an interview. I think this is a good balance, that you did your research, you feel more confident talking about things. But I would say it's not a common interview, right? As I said, they can ask you any interview question they want. They can ask you system debugging interview, just that the percent of those interviews is so much smaller than the amount of kind of regular coding questions you will be doing over the course of your life. And yeah, take-home assessment and automated test, in a way, I think it's a good way. Remember, companies are doing them to be able to cast a wider net. They don't have infinite resources to interview everyone. So if you don't have the perfect resume, essentially this is just giving you a chance to prove yourself, whereas some other company which doesn't do this automated tests may just have to pass because they think it's risky to interview someone who doesn't have a traditional background. So there is a positive lens to see all these. All right, why don't we continue with the main question, how to prepare for these interviews. Thank you for leading me right into this. And here is a system that I kind of came up with, that there are 3 pillars. You need to accomplish 3 pillars in order to be truly ready for the technical interview. And the first pillar, well, I assume you already know a programming language, right? This is a prerequisite for this. But just knowing a language and being fluent with the language is a bit of a different story. And language fluency is what I call an ability to translate idea into code. It's quite similar to learning a foreign language. And if you are not fluent in your programming language, is similar to not being fluent in a foreign language. You know exactly what you want. Maybe you want to order a coffee. Maybe you want to check out from a hotel. But it takes you a lot of time and stress to accomplish that simple action. And that will happen similarly if you are coding in a programming language that you're not completely at ease with. So here is a good time for us to do a very quick exercise. You know, let's give you 5 minutes. Pick one of these 2 questions. If you're fast, obviously pick both, and try to write an answer in your IDE. And if you feel good about your answer, post it in the Zoom chat. If for whatever reason you'd rather DM me, also you can use Zoom DM, and I will be able to look at it and give you feedback in private. So I'm going to be quiet for 5 minutes, and please give this one of these 2 questions a go. All right, I see answers flowing in, which means that people have gotten the gist of it. And well, as I said, this is a test of a language fluency. In other words, I do want to be brutally transparent. To be successful in an interview, you need to be able to like write an answer to a question like this in 30 seconds. Like the right reaction, if you're ready for the interview, is if you are not sure why I'm asking this question, and if you think if you're in the wrong meeting. Having said that, it's very normal not to be able to write an answer. And if you found that you started looking things up, like you're not sure how to define the signature of a function, is it array length or is it array size? That typically means that you're just not familiar enough, not fluent enough with the syntax of the programming language of your choice. And well, the trick for that is that's really easy to fix. You write code regularly, ideally daily, and after 30 days, I can wake you up in the middle of the night and you'll be able to type an answer for a question like this. And well, another tip is it's better to choose one programming language. It's quite uncommon for jobs to be interviewing in multiple languages. And essentially, it's best to have put all your strengths into one programming language and answer a question very well using that language, because if you're just okay in Java, just okay in Python, well, nobody's going to be able to appreciate that, and it might be better to be really good at Java and not to know any Python at all to pass this kind of a coding question. Having said that, in case the algorithmic answer approach to these questions was not very immediate, like you were like, I have to count string characters, is there a data structure, I'm not sure, is that, what's it called, maybe it's called a map, maybe something else, that would likely be a gap in your data structures and algorithms. And well, there are some questions that can be solved with just language primitives, for loops, if statements. But in fact, the majority of the interviews requires a much better command of more advanced data structures or algorithms. And well, if you're at school, I encourage you to take a course. Otherwise, there are plenty of courses online. You can read a book, you can watch YouTube videos, free, paid, a whole variety of courses. What's important is you really invest your time and understanding into this course. It's not a course that I would recommend cramming, and use your strengths for learning. If you're a visual learner, probably you're better off looking at some YouTube videos. Personally, I like to make notes, so I rewrite content in a way that I can understand, and then I can consult these notes at a later point. I do want to give you a few caveats. Obviously, I don't know what course you are going to take, but realistically, no course is going to be comprehensible. I just don't think it's possible to cover everything. And remember that learning is a spiral. So every time you come back, you will learn a little more. And every time I come back, I also find some new things to learn. So don't think that just because you took one course, that checkbox is checked, you never need to think about data structures again. While I'm not on top of what kind of courses there are out there, in my experience, most of them don't focus on specific programming languages that much. Rather, a traditional university course would talk how does a data structure work, and how to implement it in a programming language. For example, we'll discuss stacks, and it will give you some code or an exercise to implement a stack in this programming language. But the real interview will likely be some more about, well, how do you use a stack? Or what kind of problem do you need to use a stack? And in this case, you probably shouldn't be writing your own stack. And this is kind of goes back to language fluency. In your language of choice, you do want to be familiar with the implementations of the standard data structures that are available for you. So, for example, going back to our stack example, level 1, you realize you need a stack, you start writing it, takes you time, you waste time, then you run out of time. Level 2 is you say, hey, let me look at the Java doc and figure out if there is a data structure which implements a stack. And, top level, you'll say, hey, there is Java util stack. It has been obsolete since a particular Java version, but I'm going to use this array DQ data type, and it's not synchronized, but our problem doesn't require concurrency. And the interviewer is probably going to be like, oh, wow, they know more than me. I'm going to hire them because I want to learn from them. So the more you know about applicability of the data structures you learn in the programming language of your choice, the better. And as I said, the courses typically focus less on solving particular problems, although there are developments in this space. And the third pillar, as I said, is using all this knowledge bank, applying both the knowledge and the fluency to actually solve problems. And that is the hardest piece to teach because, well, you actually need to figure out a solution to a problem using what you know, and that's typically the stressful part because you don't know what the problem is beforehand. So this actually is a good way for us to transition into the second part of our workshop, which is actually solving a problem. We're going to learn solving problems by, well, solving problem as if we are in an interview. Before we jump in, let me cover the logistics, just because once people see the question, they get too excited and they can't hear me anymore. So the way this is going to work is, well, you should already have your ID open because you answered the practice question. You will be solving this problem. You can use pen and paper, you can write it down, whatever works best for you. And I'll give you maybe 5 minutes. I don't expect you to solve a question in 5 minutes. If you are able to do it, you're probably not in the right place. You should be teaching this workshop instead. But give it a good try. Obviously, I don't have any way to check if you're giving it a try or not, but you already dedicate some time to this workshop, so why not go all the way in? And then after about 5 minutes, I'll give you a hint. So even if you're completely stuck, this new information might help you to make progress on this question. So I do ask for a little bit of an honor code. Don't Google the question. I'm not interested in seeing solutions on Google. I've seen it. This is for you. Try to solve it. If you're stuck, you can DM me or you can wait for the hint and really give it a good try. All right, now that we know what's going to happen in the next 5 minutes, here is our interview question. And the interview question, well, this is the part I didn't invent. This question I took from online. It's called, is this number happy? And the definition of a happy number is once we get an integer, we replace it by the sum of the squares of its digits, and have an example on their right. So, 19 squares of 1 and 9, 82, and you sum them up. And then you repeat this process until the number equals 1. In this case, this number is a happy number. If you don't end up with number 1, then this number is not a happy number and you should be returning false. So here's our test question. I'll give you maybe 5 to 7 minutes to give it a try before I give you further hints. And in the meantime, I'll also be able to answer any questions on the Zoom.
Could we be provided with a sample of what an unhappy number looks like?
0. All right, I have my timer at about 7 minutes, and I know that at least no one has pasted the correct answer into the chat room. So I'm assuming that people are working on it, and I wanted to share a few tips on what to do and what not to do. As I said, the problem is that we need a function that returns true or false depending on whether the number is happy. And the number is happy is when its sum of squares applied over and over ends up in 1. So what's one thing not to do? One thing not to do is rush into code. Sometimes when we're nervous, we want to get something out written, and we will probably end up something like this. Here's my loop. I apply my sum of squares function. And if that sum of squares is 1, okay, yes, number is happy, but oh, I don't really know what to do if my number is not happy. And well, this is a bad idea because you don't know the solution. If you don't know the solution, this is not going to be very useful, because maybe the actual solution doesn't require this scaffolding. Maybe the actual solution is a totally different code, and you'll need to wipe all of that out. So when I first saw this question, I was really confused. I thought, well, you know, we apply this function over and over. It spits out random numbers. The numbers are all over the place. How would I know whether these numbers ever converge into 1 or just continue in some sort of infinite sequence? And this is not the right solution. This is an example of a bad solution. I'm like, you know, I'm going to try as much as I can, but if my program runs out of stack, then I've reached the limits of my computer and I'm going to return false. This doesn't show any understanding of the problem, and this actually shows use of exception in control flow, which is a very common anti-pattern. So don't rush into code, don't produce something like that. This is another example of what you shouldn't do. Let me try 1,000 times. If I apply a function 1,000 times, hopefully I'll see number 1. And if I didn't, well, the number is probably not happy. This is a heuristic, an example of, well, something that might pass an automated test case, but won't cut it for a human reviewer, because the interviewer is likely going to say, well, what if the number 1 is going to appear on the 1,001st iterations? Where did you come up with this magic number 1,000? This is definitely not a right approach of solving this kind of interview question. So what do we actually do? There is no magic to approaching this question, but I do think that your first 5 minutes on a case are the most critical. And your first goal is to understand the question. I see a comment in the chat, sometimes I have a problem understanding the problem. Yes, that's very common. You know, if we don't truly understand what we're supposed to write, then how are you going to implement it? So in this case, I deliberately picked a question which is fairly comprehensible, but it's possible that the question is less obvious, and it's totally normal to ask what this question means. And a good way to validate your understanding and win some time is actually to come up with test cases. In my experience, they can really validate your understanding, and in an intelligent fashion. So you'll work your interviewer for this, and you'll say, so for example, if I give this number, the output will be false, and for this number, the output will be true. Well, for this problem, it's not as obvious because it's hard to come up with numbers. But in other interviewing questions, this is a good way to come up with test cases that buy time. And also they are amazing to catch inequality issues and identify edge cases. Sometimes once we're too caught up with the implementation, we forget about those edge cases. We think to implement them later, we forget. Well, in this case, some test-driven design is actually really, really helpful, because you will be noting them down and you will be running through them later. So similar to our earlier question, like what if there is an empty array? What if the array is null? Right? Or what if the array has only negative numbers? It's all good to come up and to write down those test cases. And in the meantime, in the background, we can still be thinking of the solution. And at some point, you do need to think of solution. It's okay to take a pause. I don't think it's okay to take a very long pause, unfortunately. And during this pause, you might think, is there a brute force solution? And it's typically fine to mention this solution. However, I also wouldn't rush to implement it, just because the brute force is typically very different from the correct solution. So you will waste time implementing a brute force as opposed to the real answer. But it actually makes you appear also very intelligent if you say, well, in the worst case, the brute force is this, so I already know how to solve this problem. Let me come up with more elegant ways of solving the problem. And we also look for any matches in our data structures knowledge bank. That's where we talk about the importance of this knowledge bank. And the more algorithms and data structures you know, the more questions you have seen, you're starting to match patterns with what you have already seen. You can classify, oh, this is a string question, this is a dynamic programming question, and then you can you have more chances of success to solve the question. And all we are looking is for this aha moment where you kind of got an idea how to solve the problem. And finally, sometimes for complex questions, you might want to outline pseudocode. I think pseudocode is a great tool for writing down control flow without focusing on language specifics. So depending on your language fluency or complexity of the algorithm, obviously, if you already know how to solve it, go ahead, write the code. But if you think that you'd rather try to figure out the approach without being too worried about syntax, pseudocode is really great. So how can we get to an aha moment with this particular question? Well, we can look at the limit of a function. And the limit of a function sounds really scary, like you need to have a PhD in mathematics, but I promise you, basic math is enough to understand this function. And in the beginning, remember I said, the function is spitting out random numbers. They're all over the place. How would I ever know that this number is not happy? Well, turns out that this function is actually not that random. If we look at it, if we have an input of a one-digit number, well, what's the largest this function can get? The largest number is 9, and the largest sum of squares will be just 81. What will happen if we have a two-digit number? Well, the largest two-digit number is 99. That will give us the largest sum of squares, 162. The largest three-digit number is 999. But notice how at this point, its sum of squares is less than the number, right? 3 nines to the power of 2. Summed up would only give you 243. And a four-digit number would only give you at most 324 as a sum of squares. And if we put a really large number, 10 nines in a row, well, the sum of squares is actually going to be only 810. So what we're seeing with this rudimentary mathematical analysis is that actually this function isn't infinitely growing at all. If we have a 10-digit number, the function after its first application is going to give us a 3-digit number. And once it has a 3-digit number, it will never grow back. You know, a number of 1 digit can go into 2 digits, and a 2-digit number can go into a 3-digit number. But a 3-digit number will never, ever grow into a 4-digit number. A 3-digit number will continue spitting out 3-digit numbers. What that means is that at some point, you will start repeating because you only have that many 3-digit numbers. This is what scientists or mathematicians call the pigeonhole principle. If you have a limited number of outcomes and you try more than that amount of outcomes, you are going to start repeating yourself. So the actual way that this function would behave is if we have an unhappy number, we would apply the function a couple of times on it. But after some time, these numbers are going to be repeating. And that will be the definition and the way to detect an unhappy number. And hey, the program description actually gave it to us. It says if the number is not 1, it will loop endlessly in a cycle. So the answer was always on the surface, but that's why it's super important to read that answer. But hey, actually, we didn't take it for granted. We actually proved mathematically that this number is going to be looping in a cycle. And this sequence of numbers is never going to be infinite or random. So now that we had our aha moment, we know how to detect a happy number and an unhappy number. Why don't we spend additional 5 to 7 minutes and actually try to code this up in the language of your choice? Hopefully this hint can help some folks move forward. All right. I think in the interest of time, we will be moving ahead. As I said, I don't really expect you to be able to solve it, especially if you have limited experience with programming just within 5 minutes. And feel free to take more time after this workshop to finish this. So when I left you off, we came in with an understanding that an unhappy number will be looping in a cycle, and a happy number will finish with 1. And for some of you, that might be enough to go ahead and implement this. And if your data structure knowledge bank is not that complete yet, you might still be quite confused. This is a loop detection problem. And if you have never encountered a loop detection problem, it's borderline genius to be able to implement something on the spot. But the secret is that, well, hundreds of people have spent hundreds of hours figuring out how to detect loops. And, well, why not take advantage of their inventions in order to find a way to detect loops? And typically we talk about loop detection when we talk about linked lists. That's 100% true. We ask, does the linked list have a loop? But actually, this is a variation of the same loop detection problem applied on a numeric sequence. And I thought that was quite clever because it's an application of something fairly fundamental for a new application. Most people haven't seen it play out like this. So how do we detect if something is a cycle? Well, one of the most basic ways is to just save the things you have seen. Keep track of all the numbers you have seen, and if you are seeing repeats of those numbers, then obviously you must be in a loop. And well, back to our knowledge bank, what's the best data structure to store this? Well, we're not storing keys and values, so we don't need a map. And we don't really need an array because, well, we don't know how long this array should be. We don't know how long this sequence is, and we shouldn't be using a list either because we can insert in a list by searching in a list is not very optimal. So actually the data structure that I would propose for this is a set. A set would store all the numbers and we would be able to look numbers in this. So if I was using pseudocodes to solve this problem, then I think I've seen some of the solutions in the chat already. You declare a set, and then you have a loop. You calculate the sum of squares. If that sum of squares is 1, you return true. Otherwise, we check if the number is present in this set. If we do see it, then it's a loop, and we return false. Otherwise, we add a number to the set and continue looping. And I know some people may feel concerned about this while true loop. And in general, yes, while true is never too nice because it can cause endless cycles. But hey, we just proved that this program doesn't, in fact, loop endlessly. So we feel reasonably good about having this loop, while true loop out here. And well, here is my coding sample code in Java to implement the sum of squares. And back to language fluency, using modulo and division to separate digits of a number is a very common pattern. That's another thing which you should just be able to kind of crack it up. Don't think too hard about this and take it out there. I think I've seen one solution on the chat which created sum of squares using some additional data structures. That's likely just not necessary because you can just use a couple variables to calculate this. And I think I've seen one other solution which converts a number to a string and then reads it by character. That's also something I see quite a bit. I wanted to avoid it because in Java, string memory management is a little tricky, and I would not want my interviewer to start grilling me on that all of a sudden. So I went safe with this modulo and division pattern. And here is my sample solution. Here is what it looks like in an actual programming language. And it's actually just 5 lines of code. Again, this is Java. I am having a scene set of integers where I'm adding the integers. And I'm being a little bit clever with the language here, because the Java add method will return true if the number is added for the second time, if it already exists in the set. So that becomes my condition of looping and calculating the sum of squares. And as I said, maybe for you that's a little overwhelming. I don't think the interviewer would be surprised, because remember, the interviewer has seen this problem and they answer 100 times. So if anything, I'm just showcasing that I am comfortable with data structures and their APIs. We always have a cycle. The only difference is if this cycle is a number 1, or if we're cycling on any number other than 1. And this is essentially what's determining whether a number is happy. For the reference, this solution, this problem is considered easy on a popular interviewing website. And well, do I think it's easy? I'm kind of in between. I think with a hint, it's possible to solve it. Again, if you've never seen this kind of problem, if you've never used loop detection, if you've never studied data structures, I wouldn't expect you to be able to solve this problem. The reason it's called easy is because, well, our industry has progressed enough, and a lot of people have already implemented this solution, and the level of novelty required to implement this solution is rather low, right? You're not inventing a new loop detection method. In fact, you are just using something that's fairly well understood here. And well, I personally think this is an attractive solution, and I'm happy with that. The interviewer might ask you, can I do better? And the answer is yes, we can. I wouldn't say it's a drawback of this particular problem, because we are storing every number that we have seen, and that set can grow not too large, because we just proved that it's never going to be too large. But if we are doing abstract linked list detection, a linked list can be theoretically very large. And people have asked, well, is there a way to detect loops without storing every linked list node I have seen? Because maybe my list is so long that I don't have enough memory to store all the nodes. And yes, turns out that there is a solution, which I count as a bonus solution. And it's called Tortoise and Hare, after the famous fable, with which it doesn't have much to do other than the name of the animals. And this algorithm goes like this, that if you have 2 pointers, one is fast, like a hare, and the other one is slow, then if they're moving over a line, a faster pointer will never ever meet the slow pointer, right? Like a faster pointer will just only reach the end of the sequence first. But if they are in a loop, think about 2 people running in a, I don't know, running in a circle. If you're running in a circle, sooner or later, the faster person is going to reach the slow person and overcome them. And again, because they're always running in a circle. So here is my illustration of how this would go. Notice how the hare is always going 2 steps ahead, and tortoise is moving 1 step ahead. And here they are. Tortoise just entered the cycle, and hare is already halfway through the cycle. And it's only a matter of time till they meet, right? This is the magic moment. Because they met, this is a cycle, and well, in this case, this means the number is not happy. So this kind of algorithm is called informally Tortoise and Hare. Otherwise, it's called deployed cycle detection. I think someone who proposed this in the Zoom named it fast slow pointer. That's another terminology I've seen. But essentially, you are having one slow pointer and you're having one fast pointer. And then what we're going to do is we're going to calculate the sum of square once for the good one, and the sum of square twice for the fast one. And then we're always going to compare slow to fast. If they're not the same, that means we are at the end of the loop. As we said, we're always having a loop. And if the loop finishes at 1, then the number is happy. So again, fairly short, but I would say clever, maybe too clever for some people, a solution which doesn't require the use of a hash set or alternative data structure. Well, this feels like we've done a lot of work, but sometimes the interviewers, they ask, well, that's nice. What's the computational complexity of this algorithm? And this is actually where I disagree with some sources you might find on the internet. But let's try to work this through. We just proved that the largest number in Java is going to have at most 243 iterations through the code. The loop is never infinite, and in fact, the number of iterations is reduced drastically with each try. So I would actually argue that regardless of solution, in a practical programming language like Java, you're really having a one-time in space. You're maybe storing 300 values at worst. But you're never storing more numbers the larger your input is. So for me, this algorithm is a constant time. Having said that, if we're just doing a theoretical exercise and they ask you, well, what if it's a programming language which supports infinitely large numbers, which can, how would this function behave? Well, I would argue that as we established, we calculate the sum of squares, and the sum of squares is a loop in itself, and the larger number has more digits, hence more iterations to calculate the sum of squares, but not linearly more, right? Just a little more. So that's a log n. And then, well, a larger number needs more iterations to drill down that sum of squares into a 3-digit territory. So that's another log n, and therefore I would say that given each, my theoretical complexity is O of log n, given that the complexity of sum of square is of log n, and subsequent invocation yields a smaller number. So for number n, we would do log n loops. And well, the space would depend on the algorithm we implemented. If we are having a hash set, we will be using a log n. And if we are using the Floyd cycle detection, then we would obviously use constant space, given all we're storing is 2 numbers. All right, well, congratulations. You've made it to the end of this workshop. I've seen people post some really good solutions online into the chat. So thanks a lot for giving it a try, giving it your best. If you couldn't finish it, as I said, don't be discouraged. Try it out after this workshop or tomorrow. Work through it with pen and pencil, and eventually it will only get better. And well, that concludes our workshop, and we can spend the remaining 20 minutes or so with any questions that people have.
Not so much a question, but maybe like sharing a resource that the others might not be aware of. But there's websites like LeetCode where you can get a hold of problems of varying difficulty levels and have your go at it.
Yep, definitely. The only way to practice problem solving is to solve problems. That's, I think, the fallacy, which sometimes people just study data structures and like, well, I know data structures, I'm ready for an interview. Well, it's one thing to know what a linked list is. Another thing to know how to detect a loop in a linked list. And the third thing, to apply this algorithm to a problem like this one. And the only solution to that is practice. No one gets it on the first try. Anyone else has any questions? Not necessarily on this question, but anything with respect to interviewing.
I can ask a question.
Go for it.
Hi, I'm Leela. I just wanted to ask, when was because I know you said that you landed your dream job. So how many technical interviews did you have before then, or was it kind of like your first one before you landed the big deal?
Well, did I say on my dream job?
Well, I thought that's what you said.
I landed some really good jobs. I hope my employer is watching. Yes, my dream job. I made it. As I said, the numbers are pretty large. Like, I wouldn't be surprised to see high amounts of rejections. I think for more entry-level talent, it was more sending resumes and just not ever hearing back. But once I heard back, I kind of had a higher chance of passing. But remember, this was 15 years ago. The expectations were lower. The market was different. For more senior talent, I typically hear a very high amount of time after someone sees my resume. But at the same time, they fail me all the time because they just have so many expectations for more experienced talent.
Thank you.
But yeah, overall, I would definitely recommend, well, as I said, you should try solving problems. Having said that, I think those language fluency tests I had in the beginning of the presentation are helpful. If you couldn't quite answer the language fluency test, or this presentation seemed overwhelming, probably it's too early to interview. You're just going to kind of burn your chances unnecessarily. You can always re-interview, it's never final, but nonetheless, you do want to be in a certain interviewing shape before you accomplish, you kind of get your feet wet with the interviews. And it is quite normal to be preparing. I would say that's one just feature of the profession, that you probably will be spending a lot of time preparing for interviews, even if you are a full-time engineer already, in time you're changing jobs. So that's kind of a never-ending process. And you know, once you start doing interviews, typically you get more at ease with them. And even if you had 10 or 20 interviews and you didn't get the job, I would still say it's not the end of the world. You can still keep trying. But if we're talking about, you know, numbers, maybe 50 or 100 rejections, it's worth doing some sort of a practice mock interview with someone who can personally simulate an interview environment with you and give you feedback in case you're doing something terribly wrong, and they would be able to pinpoint and give you advice on what are some things you might want to improve in order to increase your chance of success. And I see that people posted a lot of resources over the Zoom. I mean, I think these are fairly well known. It's not the world's biggest mystery. There are a lot of good resources available for preparations and data structure and testing your program solving.
Hi, Diane, I have a question. So I want to be a front-end developer, and I'm just wondering if these like coding interview questions are going to be somewhat easier for the front-end developer. Like, do the companies provide different questions, sum of questions for different roles, or are they all the same?
Certainly. Well, I'm not a front-end developer, but I do know that at least front-end loops at my company are quite different. Remember, not simpler, different.
Yeah.
So typically interviewing for specialty roles, which would be anything like a DevOps engineer or a front-end engineer, would also assess practical skills in that area. Having said that, I would still expect to have 1 or 2 coding rounds of similar to what we did with the standard coding. So I don't think that you can be hired as a front-end engineer if you like completely don't know how to code or have never solved a programming question like this. This might be comparatively more easy than that of a back-end engineer, or they might put less weight on it, but I would still expect to see it in an interview and prepare for it.
I see. So one more question. So as a front-end engineer, like would it be like, would the projects that I did be more important than the coding interview? Like, do you think that the projects, like the quality of the projects actually count? I mean, do they actually look at it? Like...
Disclosure, I'm not a hiring manager for front-end teams, so I don't know. But for all I've seen, as I said, these projects would get you the interview. But once you have the interview, they stop mattering, and they're probably going to look at your interview performance and not going to say, oh, you know, they bombed the interview, but this thing looks really nice. We should hire this person. Because again, they have also very limited proof that it was you and not somebody else who did these projects. But of course, word of mouth, if you have worked with someone who can actually vouch for you and say that you did this work, it was amazing, then I have seen that having weight in the interviews. But again, not a replacement. Like you cannot be hired without an interview unless it's like a smart startup or your friend is hiring you.
Thank you.
All right. Anyone else has any questions? I know there are questions about resources, but I'm just not necessarily the best person to share resources, especially for entry level, given that I passed that level. All right. Well, it sounds like everyone had hopefully a good time, and I know that there are people here who are in different time zones. So thank you so much for staying late, especially East Coast, other people, and everyone from all over the world. Thanks a lot. And yeah, this concludes our workshop.